So in this video, we're going to learn how to take our C# knowledge of drawing things to the screen and kind of take it to the next level and allow us to create a navigatable world. In this case, we're going to make a maze, which here's the title screen. It tells the player to use the arrow keys to move and try and reach the goal, which is this green X. We press enter. We can actually see that if I press the arrow keys, I'm moving around a world, and it's a little game world. It's drawn with ASCII characters, but it feels very different from the things that we've created before. So in line with the kind of menu system that we made before where we could use the arrow keys, we're going to use a similar structure to be able to create this game world that the player can move around. It's going to open up the possibilities for your choose your own adventure games that you're making and allow you to do a lot of stuff that you might not have thought you could do with a console application previously. So before we dive into a project, we should talk at a high level about what exactly is going to go into this project. So there are two big concepts. One is the idea of a game loop. And this is something that you will find in every game engine, that there is some core loop that's running repetitively that updates your game and renders things to the screen. So we're going to have a game loop that looks something like this. We're going to get the input, which would be the arrow keys that the player has pressed. We are going to update our game logic. And what counts as game logic is going to depend on the kind of game that you're making. In this case, our game logic is move the player if they're not blocked. That's our game logic. But a more advanced version could involve things like checking whether the player has picked up a key and letting them unlock a door if they have the key, or it could be moving enemies around a screen every time the player moves. There's all sorts of stuff that could go in here. And then what we're going to do is render everything to the screen. So we're going to draw our game world, we're going to draw our player, and when we finish that, we're going to go right back up to the top of our loop and start this process over. So it's similar to what we did with our menu system where we listened for input, cleared the screen, redrew things. It's the same deal. We're going to listen for input, we're going to update the game, render, and then we're going to keep doing that until the game ends. So that's the core structure of our logic. And then the other thing that we should talk about is how are we actually going to represent a world that is two-dimensional like this in terms of code? So previously we were able to use a single dimensional array to show a bunch of options to the screen. And if we take that same concept and take it to the next level, we have a two-dimensional array here. So we have a bunch of characters, each with an X and Y location that we want to draw to the screen. And that's perfect for using a two-dimensional array. So if we flip back here, let's sketch out what that looks like let's do a simple 3x3 where let's use plus to indicate walls. I will say that the goal is an X, and we'll start the player over here. So they're going to start at the top left, try and walk around the walls, get to the goal. Dead simple level. We can represent this as a 2D array. So that would look something like this, where we take this structure and we are going to put it into an array that has a bunch of arrays within it. So I'm going to create an array here that has 3 rows to match the fact that our game world has 3 rows, and we're going to have each of these arrays have 3 elements. So that's going to give us 3 columns. And then what we're going to do is just fill them in with the corresponding characters. So we have a blank, a plus, and then an X for the first row. Then we have a blank, a plus, and a blank. And then we have a final row that is all blanks. And so what we need to do is figure out a way that we can loop over this structure and draw each character at the right place on the screen to create that game world. And then on top of this, we could draw the player in wherever the player is located and any other objects we want to draw in the world. The key to what we're going to do this time that's different than what we did last time in terms of drawing things to the screen is previously when we've drawn things, we've used WriteLine, for instance, that displays a full line of text and then moves us down, and the next time we write, we draw a full line of text and a full line of text. But if we have this game world that we want to throw the player in somewhere, we kind of need the ability to go anywhere on the screen and draw the player. Like maybe the player is here on this frame, so we want to look to the second row, third column, and draw the player here. And so there's actually another way that we can use the console that's more flexible for drawing things to the screen that's going to open up a lot of possibilities. And that is with the console's set cursor position method. And we give it two parameters, the left and top position for where we want to draw, or you can also think of that as the X and Y position. So we're saying where horizontally on the screen to draw and where vertically on the screen. So that moves the cursor to a particular location, and then the next time we call right, if we were to say right the player, which we're going to represent as a little circle, that's going to draw this circle at XY on the screen. So we could put that at 0, 0 on the screen. We could put that at 3, 3 on the screen. It's up to us to change the position. But basically, we no longer have to do this line by line structure. We can now put stuff anywhere we want on the screen. Okay, so last thing let's do here is talk about what classes we're going to need in our game. So we're not going to do the full UML, but we'll at least map them out so that we have some idea as we're working through our code, what goes in which file. So we're always going to have program, and that's going to have our entry point. So I'll throw that over here, program. We are going to have a world class, and this is responsible for holding on to our 2D array and drawing the world. We will also have a player class. And the player is going to have like an X and Y location and can draw itself to the world. Those are the world and player's responsibilities. Then we're going to have a game class over here that is responsible for our game loop. So it's going to handle talking to the world, telling it to draw itself. It's going to handle talking to the player, telling it to move the player when the arrow keys are pressed, and telling the player to draw itself. So the game is going to be orchestrating everything. So let's actually flip over to Visual Studio and get started. I've got a blank .NET Core project set up here that I will quickly set up with our skeleton, and then we'll get cooking. So I'm going to create those classes. We're going to need a player class and a world class and a game class. So I've got all three of those, and let's create a public void start method here in our game that will kick off the game running. And we can leave our world blank, our player blank, and in our program, let's go ahead and create a new game and tell the game to go ahead and run. Whoops, go ahead and start. And then we can start testing out some of our C# knowledge here inside of start. Let's get something running first. So using static system.console, I'm going to bring in the system console namespace so that I can, or the system console class, so that I can then write line without having to do the fully qualified path. And let's say the game is starting. And then let's do write line, press any key to exit, read key, so that our console will stay open. And let's put some white space in here. So nothing new, just the same skeleton we've been creating in past games. Game is starting, press any key to exit, but it's good to always have something simple running before we start doing anything new. So the first thing I want to do is look at the set cursor position documentation, figure out how we can put an individual character at any location on the screen. Then we can look at how we can use a two-dimensional array to represent a game world and use set cursor position to put any of those characters on the screen. And then we can start getting into putting all of that into our class structure. So for the moment, we're going to work inside of start, do some sample code to make sure that we understand how the new pieces work, and then we'll really get into it and add the player moving around the world. So first, looking at the documentation, I have the set cursor position documentation pulled up. It tells us that it sets the position of the cursor. It takes a left and top parameter passed in. And if we look at the description, the left is the column or the X position, and it starts on the left-hand side, goes to the right, starts at 0. So if we pass in 0, that is the left side of the screen. If we look at the top, this is the row position, or this would be your Y, and rows are numbered from top to bottom, starting at 0. So if we say 0, 0, that's our top left position. If we say 10, 0, that is 10 columns over, but we're still at the top of the screen. We'll play with these and get a sense for them in code. I also want to point out that there are a couple of exceptions that can be thrown. So if we try and specify a negative position for the left and top, that's going to cause an error. And if we try and set a position where there isn't a buffer for us to actually put characters on the screen, for instance, if our screen width and screen height were only 5 by 5 and we tried to put the cursor way off the screen, exceeding our sort of internal buffer of memory, we will get an error. So we'll keep those in mind. We're probably not going to need to do any error handling in this game because we're always going to make sure that we're putting things within our screen size. So let's flip back and try this out. So let's draw something at 4, 2, and let's make it an X. So if we run this, we take a look at what we've got. Remember that it told us it started counting at 0 for the left and top position. So our X position, our left here is 4. So it's 0, 1, 2, 3, 4. So it's actually 5 columns over from the left edge. And same thing for the top position here, which was 2, 0, 1, 2. That's actually 3 rows down from the top of the screen. So now that we've got the ability to draw an individual thing, let's make sure that we know how to draw a whole grid of things. So I'm going to create a 2-dimensional array of strings. I'm going to call it grid. And into this array, I am going to create, let's do 3 blanks. And we'll copy and paste that. So here we have a 2-dimensional, a 3 by 3 2-dimensional grid of strings. And we're going to put a test pattern in here of numbers in sequence, 5, 6, 7, 8, 9. And this will make it really easy for us to tell if we drew it correctly. If the numbers show out of order, we've done it wrong. If they show in order, we're good. And then we can replace this with an actual map and start making it bigger and getting closer to the example that I showed you at the beginning. So to loop over this, we want to go through the first row, and then for that row, we want to go column, 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 pull out each element one at a time, draw it to the screen, and then move on to the next row, and then to the next row. In order to do that, we need to know the number of rows and the number of columns. And one way that we can do that is the getLength method. And we can specify 0 for telling us how many rows there are. And if we do the same thing for columns, but we say 1 for the dimension, that'll give us how many columns there are. And so then what we can do is create a nested for loop structure that allows us to go over this grid. So we can create the outer loop, and let's do y equals 0, y is less than columns, y is less than rows, y plus plus. And same thing, x is 0, x is less than columns, x plus plus. And now we have a 2-dimensional structure here that goes for the y positions. So that would be our rows from 0, 1, 2. And then for each row, it's going to go through all the columns, 0, 1, 2 for the columns. And so we can, inside of here, grab the element that's in our grid at the x and y location. So when we reach into a 2-dimensional array and grab something, we want to specify the row followed by the column. So the row followed by the column. Then we can set the cursor position, and here we're going to specify the left first and then the top. So this is going to be x, y. And then we are going to go ahead and write our element at that location. And so if we cross our fingers, hit play, we should hopefully see our grid show up. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's drawing over what we had before. It's completely fine. We'll get rid of that in a second. But we've actually drawn our grid correctly. So let's close this, zoom back out, get rid of the game is starting. And let's just review the structure really quickly. So we have a loop that's going for the y positions, and in our game, we can think of y as being the row and x as being the column. So we're going through the rows or the y positions, and then for each one of those, so when y equals 0, we are in this row, and we're going through each column, which is our x position. So 1, 2, 3. And one of the tricky things here is that the syntax for accessing something is flipped from the syntax of our cursor position. So here we specify the row comma column, and here we actually have to specify the column comma row. So as long as you keep those two straight, you should be good to go from here. What we can do now that we've set this up so that it is programmatically pulling the rows and columns from our two-dimensional array is use whatever array we want. We can use a much bigger one with a different number of rows, different number of columns. So I'm going to grab something that I took a minute to create off screen, paste it in. So here's a little game world where the player starts here and they can kind of like walk around this wall, and get to the exit. So the number of rows and number of columns have changed, but we don't have to do anything different about our code. This will render our game world where the player can, walk in, walk down, and get to the exit. So we have all of the pieces that we need to be able to create larger game worlds here. Now what we can focus on is refactoring this code that we just put inside of game and putting it inside of our world class. So our world is responsible for holding on to the grid and being able to draw it on command. So we will need a place to store our grid, and we also will need a place to store the rows and columns of that grid. So we can create a constructor, and the only thing we're going to need to pass in is a two-dimensional array of strings. We will call that the grid, and we can use that to fill in our private field. And then once we have our grid filled in, we could go ahead and calculate the number of rows and columns. So the number of rows is going to be equal to grid.getLength. This is just what we were doing in the other file, 0. And then the columns is going to be grid.getLength, 1. And then we can take what we were doing in the other file and put that into a draw method. So this doesn't need to return anything. We're just drawing. And what we want to do here is loop over the rows and columns. So we're going to do the same structure for int y is 0, y is less than the number of rows, y plus plus, and for int x is 0, x is less than the columns, x plus plus. And we can do the same. We are going to get the element, string element is equal to grid with a capital G. And here we want to pass in the rows, columns, so y, x. And then we want to set the position, set cursor position to x, y. And since I'm using the console method here without saying console.set cursor position, I'm going to hop up here and using static system.console. So if I scroll back down, we can write the element. So we should have everything that we did in the other file now in our world class. So instead of just creating a bunch of local variables, we have created a class that wraps up all of that logic, and we can tell it to draw. So we should be able to come back here and get rid of this, create a world using our grid, and then call myWorld.draw. There we go. Same thing. It's working. The other thing that we're going to need our grid, our world to be able to handle is we want some way for us, when we're trying to move the player around, to know whether a current position in the grid is a position that the player can walk to or not. So in this case, our player is a circle and they can walk to any spot that's blank or has an X in it, but they can't walk through these walls, which we're representing using equal signs. So what we want to do is create a new method inside of our world, and let's call it isPositionWalkable, and it's going to get an X and a Y. And this method, what we want to do is return a Boolean if the grid at X and Y is open for the player to walk to, and will return false if it's not open to be able to walk there. So we can return grid YX equals a blank, which would be walkable, or if the grid equals an X, we'll consider it walkable because the X is going to be the goal for our player. And you know what? We also probably want to do a check here first to make sure that the X and Y are actually within our grid, so that they're actually valid locations that the player could walk to. Because if someone passes in -1, -1, we want to say, no, you can't walk there. That doesn't actually exist in our world. So we can say if the X is less than 0, so that would handle -X, or the Y is less than 0, that would handle -Y. And if the X is greater than or equal to our number of columns, or the Y is greater than or equal to the number of rows, we can return false. And so once we've checked the bounds, then we can go ahead and check if the grid is a walkable tile. So let's test out this method and see if it works. So we're drawing our world, and then let's also print out my world.isPositionWalkable. Let's pass in 0, 0, which should be this location. And let's pass in 1, 1, which should be this location. And let's pass in 0, 1, 2, 3, 4, 5, 6 for the X, and 0, 1 for the Y, so that we actually check whether the exit is walkable. So this should be, if we run it, we expect this to be true. We expect this to be false because 0, 0 is a wall up here. We expect this to be true because it's a blank, and we expect this to be true because it's the exit. So if we run it, we can see false, true, true. So it looks like our method is working. So we have basically everything that we're going to need for our world to be able to draw things to the screen and to be able to check whether the player can move somewhere. So we can start working on our next class. I think what we can work on next is our player class. So our player class is going to be pretty small. We need it to represent the X and Y position so that we can move the player around and have it draw on command. So we're probably going to need a constructor, and we're going to need a similar draw method so that we can draw the player. And we're going to need, let's create a public int X. So this is a public property called X that has a getter and a setter. This is going to make it so that our game class can create a player and move it around to new locations in the world. That's why it has both a public getter and a public setter. We're going to do the same thing, but for Y. And then we can create some private fields, so we can create a string, which is the player marker. This is what we're going to actually draw wherever the player is in the world. And we can also create a color that we can use, console color, for the player color. So our constructor, we're going to need to tell the player, we're going to need to create the player at a specific location. So initial x and initial y. So we're going to pass in an x and y, and then we can store those into our x and y fields, x and y properties. And for this, let's just say our player marker is a circle, an O, and our player color, let's make it something that'll stand out while we're debugging, console color.red. So then what we can do down here inside of our draw is set our foreground color equal to our player color. And I'm going to bring in using static system.console. We will set our cursor position to that x and y location. So x, y for top and left. And then we will write our player marker. So that's just drawing a circle there, an O. And then after we're done, we can reset the color back to the normal color. And we've got one error here because I used the lowercase y up there. So we've got a pretty simple player class that's just responsible for being able to draw itself to the screen at whatever its x and y location is. So let's try creating that inside of our world, inside of our game. So we've got our grid. We can get rid of our test code here. Let's create a new player. And let's put it at 0, 1. So we'll put it at 1 in the y, and then 0, 1. We'll put it at 1 in the x and 0, 1 in the y. So let's do 1, 1. And we can get rid of this and just put a blank. So we create our player, and then we should be able to tell our player to draw itself. And hopefully we'll see our world show up and then our player get drawn here. Oops, let's get rid of this text. Since we're moving the cursor around after the player was drawn, this is drawn right after wherever our player was drawn. So let's just get rid of that temporarily. We'll talk about how to fix that in a bit. But there we go. We've got our player showing up where we were thinking we were going to put it, and we can now try and move it. So instead of putting it here, let's put it where we actually want it to show up to start, which would be 0 for the x, and then 0, 1, 2 for the y. So 0, 2. There we go. So our player is showing up in our starting location. We've got our world. And now we can start building our game loop and putting all of this together. So we've been working fast and loose here and putting everything inside of start, but if we want to be able to create our game loop, so private void run game loop, we want this method to handle going through, getting input, drawing everything to the world, checking whether the player has reached the exit, and then sort of just restarting that whole process and continuing to go until the player exits the game or reaches the exit. So to be able to use the player and world inside of this method, we actually want to bump these up to be fields. So we want to create a private world field that we can call my world, and a private player field, current player. So instead of creating a local variable here, we will put this into my world. We don't need to draw anything inside of start. Current player. And we don't need to draw the player either. So our start method is just going to go ahead and create our grid, our world, and our player. And then it will go ahead and kick off this run game loop method, which will create a loop that's going to run forever. And this may seem scary at first, but what we'll do is make sure that our loop has a break statement in it at some point, which will kick us out of the loop at the appropriate time to end the game. So what we want to do here in our loop is draw everything. Then we want to check for player input from the keyboard and move the player. Then we're going to want to check if the player, check if the player has reached the exit and end the game if so. And we're gonna have to do one other thing that we'll talk about when we get there, but give the console a chance to render. So draw everything. We already know how to do that, and let's keep this clean by putting it in a another function here. We'll call it private void draw frame. So this is going to draw an individual frame of our game. It's going to clear the screen. It will have to draw our world, and then it will draw our player. And it's important that we draw them in this order, because if we draw the player first and then the world, we will draw over the player. So really we're kind of doing a Z sorting or depth sorting here by drawing the world first and then drawing the player on top. So we can throw that into our loop here. We can draw frame. Let's create a method, private void handle player input. And we will fill that method in a minute. So this is going to go ahead and read from the player and move the player's X and Y position based on whether the arrow keys have been pressed. This we will just leave a to-do note for us to do this later. And then giving the console a chance to render. Well, let's run it and see what happens. So we're seeing something happen. It's clearing and drawing really, really fast. And so one of the things that we want to do in our loop here is make sure that we're not drawing so fast that we never see anything rendered to the screen. And so we can give the console window a chance to render itself by using the threading namespace called the sleep method of the thread class. And here we can say how many milliseconds we want to stop the game from running. So we're not going to accept any input. We're essentially putting the processor to sleep. So nothing should happen for, let's say, 20 milliseconds, which is a really small amount of time, but it's actually enough time to give us a chance to see everything appearing to the screen. So now we can actually see everything because we're doing this infinite loop where we're constantly clearing and redrawing. We're going to get this flickering effect, but that'll go away when we wait for the player's input. So let's do that now. We are going to close this, and we're going to go into our handle player input method. So handling the player's input, this is going to look really similar to the menu that we created before. So let's create a console key info variable. It's going to be, let's call it key info. And we're just going to read the key. So whatever gets pressed, we're going to get the console key info here. And we know that we can extract the console key from key info using the key with a capital K property. And then we can write a switch statement. So we can say switch the key, case console key dot up arrow break. And we just want to do this for the down arrow, the left arrow, and the right arrow. And our default, we can just put a break statement in here. So we've got our switch. It should run on our key. This should run if we get the up arrow. This should run down, left, right. So all we need to do is modify the player's position When they press up, we should move the player's Y closer to 0. When they press down, we should increase the player's Y. And we got to do the same thing for the X here. So let's fix this error. I'm missing a semicolon. So if we press the up arrow, we want to go ahead and grab our current player. And we'll take its Y position and subtract 1. If we hit the down arrow, it's going to be current player.y plus 1. Left arrow would be current player.x minus 1. Right arrow, current player.x plus 1. So we're going to have to integrate our is position walkable code here, because right now we're just completely ignoring whether or not the player can move to that position, and we're just moving them there. So if we run this, we can press the left and right and up and down arrow keys, but we're just completely disregarding the walls, and we can move outside of the bounds of the map, and we can actually crash the game if we try and move to a negative position. So we're getting that argument out of range error. So let's fix that. We can close this, go back to our game, and instead of just letting the player move just regardless when they hit the up arrow, regardless of the map when we hit the up arrow, we actually want to talk to our world. So we want to say if our world is position walkable, and we're going to pass in the current player.x, current player.y, and we're going to do this modification here where we're going to say not just the xy, we're going to say if the position above the player is walkable, then we're allowed to change the player's y position to be -1. So if I go run the game now, I've got a wall above me, so if I press the up arrow, we are blocked. And if I press the right and then try and go up, we're blocked by the top wall. So all we have to do is take this same logic and apply it in all of the dimensions. So here, this is the position below the player walkable? Then let's let the player walk there. And here we want to say, is the location to the left of the player walkable? And here we're going to say, is the location to the right of the player walkable? Then we'll let them walk there. So if we save it, run it, we should now be able to walk around without without clipping through any of the walls. We can't walk off the map, and we're able to step on the exit. So now, to kind of finish the game logic, all we have to do is check whether the player has reached this exit location, and then be able to end the game. So let's close this and let's start working on that. Zoom out here so we can fit more on the screen. So down here, we want to check if the player has reached the exit, and if so, then we can end the game. And what we kind of want to do is like somehow get the position from the world, get what's at the player's position from the world. So we want to be able to say like the grid and then pass in the player's position here. But if we look at our world, we've made the grid private, which means that other pieces of code can't just like directly reach in and change the level willy-nilly, which is actually a good thing. We kind of want to restrict access here. But what we can do is create a method that lets us maybe get access to the character at one of the locations in the grid. So what we can do is public string get element at int x, int y. And what this method lets us do is return a copy of whatever is in the grid at the x and y position. So using this, we could then ask the world, what is at the player's X and Y position? Is it the X, which means that we've reached the exit and we can end the loop? Or is it something else? If you want to add other features to your game, you could check whether it's like some kind of trap or whether it's some kind of enemy. You could do all sorts of things with this. But let's just check for the exit. So what we can do is, let's say element at player pause is equal to my world.get. And here we're going to pass in our current player.x, current player.y. So this will give us the string that's underneath the player. Whoops, this is get element at. What we want to do is if the element at player position is equal to x, this is when we can break our loop and exit the game. So if I run it, step on the X, and our game ends. Obviously, that's not a very graceful way to end the game, so we can spend a few minutes cleaning this up, but that's kind of the core of the logic for creating a world that we can explore. What we should really do is when our game loop, right before it starts, we kind of want to display an intro, and then afterwards display some kind of outro. So let's create methods for that. I'm going to create a void display intro method and a private void display outro method. And for these, I'm just going to paste in something that I wrote before. So here is our intro where we welcome them to the maze. We print out the instructions. So we're saying use the arrow keys to move. We are telling the player that their goal looks like this. And we're using right here so that we can put some colored, we can put a green colored X on the same line. So we print out the X and then we tell them to press any key to start. And then for outro, we can clear the screen, say that they escaped, thank them for playing, and tell them to press any key to exit. So then using these two, we can make our game look a little bit better, display intro. And when the game ends, display outro. And give it a whirl to see if it works. So welcome to the maze. Looks like I forgot something already. Let's close this. Should have done a reset color here to take the color back to the defaults. So let's try that one more time. Welcome to the maze. Use the arrow keys to move, try and reach the green X, press any key to start. Can move around. When we reach the X, you've escaped. Thanks for playing. Press any key to exit. So this is looking great. We have the basics working, and now we could focus on a few advanced things that we could add to this. So first up, let's look at making the world look a little bit better. So for instance, in our instructions, we said get to the green X, but the X that's in our level is not actually green. So what we can do is in our draw method here, we can change the color based on whatever element is being drawn. So instead of just doing a right after we get the element, let's set the foreground color. If the element is equal to X, then our foreground color is equal to console color green, else. And the color that our app is using for the rest of the text is white. So if we run it, we should hopefully see a green X in our level. Good. Can escape. And when we ran it, I noticed that inside of our game, I forgot to add two things to start. So one, our title bar here is this gibberish location of where the file is located. Let's change that. And let's also change our app so that we don't have this cursor drawing over our world. So we can close this. What we want to do is change the title to be something like "Welcome to the Maze." And then there's inside the console class, there's a cursor visible property that if we set to false, that will make sure that the cursor doesn't show up on our screen. So no cursor flashing here, and when we go to this page, no cursor showing up on top of our maze. There's a whole lot more that we could do to improve this, and in the next video I'll show you some of those things, but I want to leave you with one more cool thing that you can do with this. And so we can use any ASCII character in our map. So we've got our normal sort of 0 through 126 characters, which are the normal English alphabet, but if you use some of the extended characters, like if I choose this block and copy and paste it, and I'll make sure this link is in the canvas, we can flip back, and instead of using the equal sign here, I can select everything, hit Control H to do a find and replace. I can look for equal sign and replace it with our block, replace all. And now when we run it, we should see a level that looks a little bit more pictographic than before, where we've got these blocky walls that look a little bit better. So I'll leave you with that. In the next video, I'll talk about how to create a level from a text file as opposed to having to create this 2D grid by hand, which will open up some possibilities, like we'll be able to use ASCII flow to design levels as mazes and then export them as a string, put it in a text file, read it in, turn it into a level. So that's a sneak preview of next time, but you have the building blocks here to actually build some cool structures yourself. So feel free to integrate this into your choose your own adventure game and have fun with it.